Great, so I'd like to introduce Alex Guazzelli, Dr. Alex Guazzelli from Cementis. Alex is an expert in PMML, predictive. Help me out here, sorry.
Modern markup language.
Thank you.
There we go.
Sorry. I'm tired. I'm jet lagged. My body went blank.
It's even hard to say PMML, so you did a good job.
PMML, that's right, yes, thank you very much. And he's Vice President of Analytics, I believe,
Correct,
at
yes.
Cementis, and involved in the whole analytics thing, predictive analytics, and hence PMML. I cannot say it, I'm incoherent. 8 hours up, my time zone. Welcome to Alex.
Thanks, Charles. Thanks for the organizers. Great to be here. It has been 2 years, so it's really a pleasure to come back. So the title is When Big Data and Predictive Analytics Collide. It's really just, I was trying to think of an interesting title to have people pay attention, but I'll be talking about PMML, as Charles alluded to. But PMML is part of, this collision course of big data and predictive analytics, and I hope I can show you that. And, when two things collide, you can have good things or bad things out of it, right? Usually you have new things that come out of a collision. So I'm hoping that I can show you that. It's fascinating. I mean, everybody's talking about big data these days. I mean, we've seen quite a few of the speakers talk about big data. But, how does it differ from predictive analytics? And in my knowledge or my view of big data, predictive analytics is actually part of big data. So when people talk about big data today, they're actually talking about the techniques to also solve the big data conundrum or the challenge of, getting value out of big data. So the outline, I like to make the outline questions. So these are the questions I'm going to try to answer. So I'm going to be talking about a little bit about predictive analytics and big data, obviously. What is predictive analytics? Give you an example. What is big data? What is the big deal about big data, right? Can you show me a predictive model that uses big data? I hope I will do that. And what now? And then, in this course of collision, I'm going to try to introduce PMML to you, which is the predictive model markup language, which is the standard to represent predictive solutions, big data or not. So what is PMML? I'll try to define that, what it's made of, who supports it, what are the benefits of using a language such as PMML to define your predictive solutions, and what's the kind of predictive workflows that you can represent with PMML. I thought the word workflows would be nice in the rules community, but I'm talking in terms of predictive workflows here. And then I'm going to talk a little bit about the perfect analytic storm, and I think we are really, in that kind of scenario. And I really enjoy being where I am now because, there's a lot of interesting and cool things being done. And then I'm going to attempt to give you a live demo. Forgive me if it doesn't work at the end. With demos, it's always dicey, but we'll try. And then talk a little bit about resources and literature. So predictive analytics, we've been talking about it the entire day here. And, analytics is a big field, and it's usually can be divided, I think, into two fields. And it's in the bottom of the slide there. It's, you can divide it into descriptive analytics, which tries to answer what happened. So, for example, the average transaction amount for the last 30 days in an account. How much did you lose for fraud in the last week or not? So there are all things that you look at data in the past and you try to come up with these values, right? And you can then have dashboards or a business intelligence kind of system to show you, and so you can give to the business folks for them to, make decisions on top of it. Now, predictive analytics tries to look forward. So given what I know, how can I, predict how things are going to behave in the future? So I had that report icon, and I decided to put the arrows there, and that's really the idea of predictive analytics. I have all this past data, and then I can analyze in interesting ways, and I can then learn patterns from that data and try to see if these patterns are going to repeat in the future, and then try to predict things, that way. So in a way, you're really using, clever mathematical techniques on top of past data to forecast the future. That's really what predictive analytics is. So I thought of an example, and it kind of, predicting churn is quite an obvious example for predictive analytics, and it kind of is similar to what Carlos was telling us about. And I decided to separate this into two populations. So let's say Matt and Scott represent those populations. Matt is someone that churned based on attrition. He was discontent and he left the company. Okay, maybe telco, let's get an example as generic as that. And then Scott is, on the other hand, actually use his Facebook to like your company. So he's a loyal customer, and so I have these two populations there. Now John, I don't know anything about John. And so I'm going to try to predict what's going to be John's behavior, given that I know Scott and Matt's behavior. Okay, so that's kind of an example of me using predictive analytics. Is John going to churn in the next few days or not? Is he a loyal customer? So here are some churn-related features, right? And this is an example, really, but it's something that we see almost every day. And this can come from ERP or CRM systems that you already have. And this is kind of the traditional demographic and information in your CRM system. This is the traditional data that people have been building their predictive models on. So, for example, Matt, he had 3 complaints in the last 6 months. He opened 2 support tickets in the last 4 weeks. Money he spent, not a lot. He purchased 2 items in the last 4 weeks. Some demographics. He lives in LA. Scott, on the other hand, had no complaints. He opened 1 support ticket, and he spent quite a bit of money with your company, and he bought 12 items in the last 4 weeks. And is a male and lives in Chicago. So like demographic information, CRM information. So they are typical features that you can try to use for predicting churn. There's many more other than this, but I'm just trying to give an example here. So turning that page into big data. Okay, so I can build a predictive model out of that data that actually works. I can predict churn, but do I want to infuse that data with something more? Do I want to bring my predictive model into the next level? And the answer is yes, right? And you would infuse then now your typical CRM, ERP data with big data, much richer data. So in a way, you want to try to have a 360-degree view of your customers. And this is, of course, for companies that are dealing with customers, but you can have, different kinds of predictive models that work with sensor data or any other kind of data. So the way I like to see big data is as an ever-expanding ocean, right? And I really like the world map for that because it captures a little bit of the view I have. I like to have images that define things. So, the ocean here, this is a topological map. You can see the Pacific Ocean or the oceans in general, they have breadth and depth. And that's the volume. I mean, big data has 3 V's associated with it, and volume is number 1, right? So it's really lots and lots of data. And then you have a variety of data, right, from different things. And I actually have some here, transaction records. That's the most common one. Social media is the thing that we all been talking about, how to use that data. But climate information, can you imagine the amount of data? Mobile GPS signals everywhere we walk now, our mobile phones are giving out our GPS location. Healthcare data. Healthcare is a huge field here because you have electronic medical records, you have X-rays, you have lab work, all kinds of data that are really encapsulating this big data narrative here. And a smart grid, smart meters, voltage, sensors, all kinds of things in the smart grid. And then the digital breadcrumbs, and that's whenever you go, and everybody's leaving digital breadcrumbs now because if you're surfing your internet, you're looking at the iPad, you're leaving all these breadcrumbs behind, right? And this is also big data. And this can be used in different ways to do predictive analysis on you. So, and it's interesting that 90% of the data today was created in the last 2 years alone. So that's a big deal, right? But I also would say that there's a big problem with big data, and that's the other V that I didn't talk about, which is velocity or speed. Big data is created extremely fast, right? All these things are creating data all the time, but I would also say that it gets old very, very fast as well. Your customer is going to change very quickly. The Facebook data is going to change very quickly. So if you don't act on that big data very quickly, you're going to actually lose the value on it, or most of the value that is in that data. It depends on the kind of data, obviously, right? So if you're using big data, you have to be extremely agile and fast. And it's a big challenge, right? Because now you have lots of data, and you have to act on it very fast to get the value out of it, the insights that you need. So I was trying to think of some churn-related big data features, and this is different than the features I showed you before. So we're now expanding our universe of features here from the traditional CRM demographic kind of data into the big data realm. So if things that I can deduct from my big data is saying, well, okay, Matt has 12 friends that share his network that are listed as my customers as well. I have 2 complaints from friends that Matt has in the last 6 months. The average age of friends for Matt is 41 years. So you see, I'm using his social network to get all kinds of information about my company and how it relates to all his friends. And friends of friends, let's say, you can imagine that too. And I can look at, digital breadcrumbs. When was the last time that Matt visited our website how many times in the last 7 days? How many pages were open? How much time did he spend looking at it? How many newsletters did he open? Did he click on any links that were in my newsletter? So as you can see here, we are really expanding the traditional data that we had more towards a 360-degree view of who Matt is and who Scott is. Now I can see, well, maybe Matt is connected to a lot of people in his network, and if these people, let's say, churned 2 weeks before, I'm going to try to mitigate their impact when it comes to Matt. And I'm going to try to keep him, right? So this is really going an extra level in trying to bring big data to make your predictive analytics go to the next level, right? But it's at the end of the day, you're really infusing your original data with big data and using all these mathematical techniques to get where you want. So this is the real, the traditional process of building a predictive model. You have the 2 populations that Matt and Scott represent. So the people that churned and the people that are loyal customers. And then you're trying to build a predictive model here. You're training your predictive model. So you're building this mapping function between the 2 populations and the target values. And you want, of course, your model to generalize. And I kind of list here on the bottom your most typical predictive mathematical algorithms for creating predictive models. Neural networks happens to be actually one of my favorites, but regression, support vector machines, scorecards, decision trees, clustering, association rules, and the list goes on and on. And more recently, actually, people are not just settling for one predictive algorithm. They're actually using several, and they are combining them together. And it seems that the idea is that 1 + 1 = 3. Actually, you can get more value that way. So you can build different models for different populations, for different parts of your big data, whatever, and you can assemble it all together using a model ensemble or different ways to put it all together. Okay. A typical example of a model ensemble is something called random forest, and I'm sure you're quite familiar. I mean, a random forest model is basically thousands and thousands of decision trees that work together to give you a prediction. So what I mentioned before is that you have to be agile, right? This big data is coming at you as a tsunami. It's really in a very fast way, and the data is going to get old, so you need to manage it very quickly. You need to be agile. You need to deploy it very quickly. And the idea here is that you build your model, and then you have to deploy now your model. You need to build your model on past data, but now you want to use this model on new people, right? On everything that happens with your clients, your existing clients, try to predict if you're going to churn or not. So you need to move this model that you built in your desktop, let's say, using data mining tools, into the production environment. You need to operationalize it. And this task usually, traditionally has been a hard task to accomplish. And this is traditional scenario of deploying predictive solutions. And in this traditional thing, in this scenario, it takes months to move your model from the scientist, the data scientist desktop, the person that was responsible for bringing all that big data and predictive analytics together into your operational system. So basically, and you here have Scott and Matt again. It happens that Scott was a data scientist. We didn't know about that, and it was not in the big data, so it was just leaving for later. And Matt is an IT engineer. They live in different worlds. They speak different languages. As you can see, Scott knows R, SAS, SPSS, Spotfire, Python, Perl. All these languages are the universe of techniques that a data scientist needs to master. The IT engineer, though, lives in a different world, right? Java, .NET, SQL. So, to have this model that the data scientist builds operationally deployed, traditionally you have to write a requirement doc, you pass it up, to your IT engineers. They don't quite understand it, they'll have questions. There's questions back and forth, and this will take sometimes months for a model to be deployed. This is not acceptable when it comes to big data and predictive analytics these days, okay? So something new needs to happen here. Something that will allow you to deploy your models in minutes, not months, okay? And that's where PMML comes in, the predictive model markup language. So PMML is an XML-based language, so it's not extremely exciting. It's XML at the end of the day. But it's used to define the statistical and data mining models. And since it's a standard, you can share this between PML-compliant applications. It's a very mature standard. It has been around for more than 15 years now. And it's developed by the DMG, which is the data mining group. Zement is the company I am with, is part of the DMG, and I'm the representative there. I've been working with the DMG for the last 4 years, or 5. It has been a few years. PMML really eliminates the need for custom deployment, custom coding of that solution. So there is no more requirements doc. You just create your predict solution, you export it as PMML, you pass to the IT folks, and they upload into a PMML compliant scoring engine, and you're ready to go. So it takes minutes, not months, to do that, okay? The other nice thing is that PMML is not just for predictive models. What I try to say is PMML is actually for predictive solutions. A solution incorporates pre-processing, like massaging your data, as well as post-processing. So PMML can even have rules at the end of the day, simple rules that define thresholds and business decisions. So the whole thing can be incorporated into a PMML file. Predictive workflows, what kind of components it has? Well, everything that you can imagine that is used to represent a predictive model or a solution. So you have input validation, outlier, missing values. This is extremely important when you move your solution into production because bad things will happen to your data. There is all kinds of data pre-processing elements, and then you have a bunch of predictive models that can be represented in PMML, obviously, and data post-processing. Not only that, you can have model ensembles, you can have model segmentation, you can have model chaining or composition, so all kinds of multiple models, multiple predictive models together in a single PMML file, or dispersed in different PMML files that talk to each other. So the benefits here. Besides, of course, avoiding custom coding of predictive solutions, there are many benefits, I think, associated with open standard, right? But I think the really important thing here is ensures transparency. So I've seen quite a bit of companies that have large data scientist teams that master different modeling environments. So one team likes SAS and they use SAS, another team likes R and they use R, another team uses Spotfire and they use Spotfire. But if everything is represented in PMML, then you have transparency, for all these things of what everybody's doing, right? Because PML then can be understood by all the teams. Disseminates knowledge, so something that's being done by one group can then be understood by the other group. Fosters best practice between data scientists, and transforms predictive analytics into really dynamic assets. It's not something that's sitting on a desktop for a while until it gets deployed, right? It's really agile. In terms of support, I may have missed a few companies here, but it's really supported across the board. Different companies support, of course, different parts of the standards. I was just talking to Jacob from Open Rules, and they are supporting actually rule sets in PMML. But it's part of the standard, and they support that. So the rules community is supporting, of course, most of the decision trees and rule sets, which is more in line with business rules. Okay. But you can see here quite a bit of companies that are behind the standard. So the perfect analytic storm here, you have big data, and then you have predictive analytics, and open standards that can make this two very agile, right? And then you have also cost-efficient processing power, and that's represented by, as Carlos mentioned, Hadoop and cloud computing. And I thought it would be quite interesting to have actually a demo of executing one of the systems in the cloud, because really cloud computing and Hadoop allow for all this processing to happen in very, even in real time. I mean, Hadoop obviously not, but you can process a lot of data in a very short amount of times. So it's really the perfect analytic storm, and we are in a very exciting period, because I think, let's say 5 years from now, a lot of things will be already set in stone and defined. So this is a period to define and get the process in order. So I'm going to show you the live demo, which I hope will work. And the idea here is that now you have PMML. And you can use any of this on the left side, any of these model building tools to create a predictive solution with normal data, with big data. And then you can export that solution into PMML, and then you would import, in this case, in the Semantic scoring engine. So we have a platform for executing models that live in the production side of the equation. DAPA would be our decisioning engine that incorporates business rules. We have it running on the Amazon cloud and the IBM cloud. We have it out for on-site. And we also have a solution for in-database scoring and Hadoop. Okay. So this is the system I'm going to be showing you. It's DAPA is our scoring engine. It's completely standards-based. There is this integration with predictive analytics and business rules. So ADAPA has rules inside it, so you can write all these rules and wrap them around your predictive models. It can be very complex. You can deploy and manage one or many models or one or many rule sets. It provides real-time or batch scoring, in this case via web service or the console, or we can do all kinds of scoring, and it's extremely fast. And it's available on the Amazon and the IBM Smart Cloud. And this is really interesting because the cloud is pervasive, right? The cloud is everywhere around the world, and we have lots of clients in emerging economies that tap into that. So this is offered as a service. And for the Amazon cloud, for example, it starts at 99 cents an hour. So if you're in India, that really matters, and you're more likely to use the cloud, to deploy your models there. Or if you are in the US and that's not a concern, then you would bring it in-house. Okay? So let's see if... So I thought of building a predictive model in KNIME. So KNIME is a model building environment that comes from a company in Germany. It's open source, so you can download and play it with yourself. It doesn't cost anything. And what you do in KNIME, you define a kind of process flow. And you have here by the way, let me show you first the data. So this is my data set, and this is all these features I showed you earlier. My original CRM, ERP data features, as well as my big data features. So I have all kinds of features here. Each record is for one customer. Let's say number of support ticket last 4 weeks, and I have, let's say, a percentage of friends that churned in the last 30 days. Okay, so I actually, as you can see, there is a lot of big data ETL that goes into this to get to this data set, and then I sample it down from millions of customers to 108,000, I think, that I use for training here. So we have around 108,000 customers representing this flat file. Okay? So let me go back to KNIME. And so KNIME has all these nodes to do all this processing for you. The CSV reader will just read that file in, and then I have dummification of variables or normalize all the features, and I bin them, and I do some other kind of processing here. And I need to get to the end here. Okay. And then I have here my neural network, so I'm going to train a neural network to predict churn for this population. And then I have a PML writer. That means the neural net is going to be exported. As you can see, these blue nodes here are just PMML nodes. So all these graphical nodes here in I actually export PMML, and they pass down the line. So it really follows the process flow. At the end of the whole thing, you have a PML file that represents the entire computation together with the neural network. Okay? So to do that in KNIME, I would just say execute. So let me do that for the neural net. And you see all this, you can see on the screen here, they have been queued. And they are, you can see the first node there. It's normalizing all the data, and then it's going to bin it. And eventually it's going to come to your neural network, and it's going to generate the neural net. Okay? And then finally, when all that is done, so it's building the neural net now, I can just execute the PMML writer node that will write my entire process into a PMML file. It's going to take a while, so I already generated a PMML file for this flow, so believe me, it comes from this. In the interest of time, I have here the KNIME neural net PMML, and I can open it for you. It's XML, so it's not extremely exciting, but I'll be quick. There we go. So here's my neural net. You can see all the neurons with the connections and all that. Let me go to the top here. There's a header that says it comes from KNIME, the version, and this KNIME, of course, was in my name, was unloaded. Then I have a data dictionary that just really specifies all the input fields that come into my predictive solution. And then I have a mining schema. In this case, also I have all kinds of treatments for invalid values and missing values that I can define in a mining schema. And as you can see here, my target variable that I use, the one I use to train this model, is called churn flag. And that's the predicted value. And then I have all kinds of transformations here. I did all those normalizations, but I also did some binning. And that's all represented in my PMML file, together with my neural network. So once I have this, how do I go around and deploy it? So now how can I use it to score all those customers to see if they're going to churn or not in the near future? Then I can basically deploy that using Adapa, and I'm going to choose the cloud here, the Amazon cloud. And we have a free trial of Adapa running on the Amazon cloud. So I'm just going to log in here to my trial. What you see here is the server view of the engine, the scoring engine that's running on a Amazon instance right now. Of course, if you have this product, it's private to you. No one else has access to it. I already deployed quite a few models, support vector machines, a generalized linear model, a k-means clustering model. I'm just going to go ahead now and upload that model so that I created with KNIME. So it's uploading it, and I don't see the OK here. Unfortunately, this is too big, too. Yeah, it's not, but I have a way to do this actually that works. So if I quit this, it's because the screen is so small that I don't see the button. So if I do that again, so I'm going to log in again, so just to show you that the mod is there. There is usually an OK button that you can click, but it's true. So here's the NIME neural net. It's deployed. That means that process that took months before took minutes, right? I build my model and I move it to the cloud. This instance could be running in Asia. It could be running in Brazil. I could access it in real time using web services. I mean, that's really how agile it can be. So, that's part of the demo. The other thing is we have actually created, you probably heard of Datamir. Datamir is a Hadoop-based company. They have this Excel Excel-looking product on top of Hadoop. And so we have a plugin for them. And so I have here Datamir running, and I have data, the churn data, and I also have some audit data here. So it's just to show you that the same thing applies. You can move your PML file anywhere. So let's see here. I have actually deployed already some models the same way I did in the cloud. I'm deploying this in Datamir on top of Hadoop. So I have a decision tree here, and I can choose a file, and the one I just built, and I'm going to add that PML file. It logged me out. That's the part of live demos. So here there's this is a plugin for Datamir. So you go to the Universal PML plugin, and then let's try it again. Now that I am. So there we go. My neural net is already now available in Datamir for me to use and score my big data on top of Hadoop. Okay? So this is as simple as it gets, right? So this, if I score this, is going to be a function inside Datamir. It's going to come up as the predictive model that the NIME model that we're building using neural nets. So that's really how PML can revolutionize this, deployment of predictive models. It comes with all the benefits of open standards as well. So going back to the presentation, that was it for the demo. I'm sorry for the hiccups. Go back here. Some resources. So I have a blog. If you're welcome to take a look. It's called predict-analytics.info. I've been writing for a while, and we have a lot of subscribers. I would welcome you to take a look at it. We have lots of content on our resources page on our website, webinars, community forums, white papers, mostly for partners, PML examples and tools. And just a few months ago, IBM was looking for someone to write a series on predictive analytics, and I was fortunate to be invited. And I wrote 4 articles called the series called Predicting the Future. And I promise to you, I actually write better than I speak. So I hope you'll take a look at it. So there is a link here. It's a developer works. It has a video. You don't need to look at the video. Please avoid the video, but the content is pretty good. So if you want to know more about predictive analytics and how it can be used, not just in terms of building a predictive model, but deploying a predictive model, it's all covering this 4-part series. And finally, thank you very much.